Hello class. Today we are going to discuss the last topic of our partial differentiation or partial derivatives. So this time we are going to discuss higher order partial derivatives. So suppose that f is a function of two variables x and y. Since the partial derivative given in this notation, partial derivative of f with respect to x and partial derivative of f with respect to y are also function of x and y, these functions may themselves have partial derivatives. So this gives rise to four possible second order partial derivatives of f, which are defined in the following. Here read it as the secant partial derivative of f with respect to x, denoted in this symbol, which is equivalent to, so we have here the first partial derivatives and we take the partial derivatives again. So we have the first partial derivative of f with respect to x, and then we take the partial derivative of this again with respect to x. In symbol, this is noted by this. All right, so we have 2 here after this symbol, and then we have 2 here after x. It's just like the square of x, and here the square of the partial differentiation symbol. So that indicates the second order partial derivative. Or equivalently, this is f sub xx. All right. So this notation means that we differentiate twice a given function with respect to x. So first partial derivative of the function with respect to x, and then we take the partial derivative of the resulting function with respect to x, and this is the notation. So you can use either this symbol or this one. Okay, so we have you have two options, either use this or this one. So that means the same thing. So differentiate twice with respect to x. Differentiate partially twice with respect to x. The other one is something like this. So this time with respect to y. All right, so we have this notation, which is equivalent to the partial derivative of the partial derivative of function respect to y with respect to y, or simply f sub yy, or f sub double y. All right, so this is the result when we differentiate twice with respect to y. Okay, so again, you can use the notation. Now you can use either this or this one to represent your higher order derivative or second order derivative. And the other one is the partial derivative of the function with respect to y and then with respect to x. So in other words, first we take the partial derivative of the function with respect to x, then after that we, we take the partial derivative of the resulting function with respect to y. Or we have f sub x and then y, means the first variable here indicates that we differentiate partial with respect to x, then after that we take the partial derivative of the resulting function, this time with respect to y. Or we have this differentiate first with respect to x and then with respect to y. So we differentiate twice, first with respect to x and then second with respect to y. Okay, so we can use either the symbol or this. Okay, And last one is something like this. Second order or the second order derivative, partial derivative of the function with respect to y and then with respect to, sorry, with respect to y and then with respect to x. Okay, so you may use this symbol or notation or this one. So take note that here we differentiate first with respect to y. The inner part here indicates that that's the uh, you differentiate it partially with respect to this one, there is variable y, and then after that with respect to x. Okay, so the last two cases, meaning this part here. So the last two cases, so it means this one here. So the last two cases are called mixed second order partial derivatives or the mixed secant partials. So these are the terms. Remember this. The last two cases are called the mixed second order partial derivatives or simply the mixed secant partials. Also, the derivative, this derivative of the function with respect to x and the partial derivative of the function with respect to y are often called the first order. So they're called the first order derivatives. So when it is necessary to distinguish them from higher order partial derivatives, then similar conventions apply to the second order partial derivatives of a function of three variables. All right, so remember this. So similar convention. All right, and warning. So be careful, class, when you're using these notations or when you're doing the process. So observe that the two notations from the mixed secant partials have opposite convention. Okay, opposite convention. You see here, y x then x y, x y, y x. So take note on this. Observe that the two notations for the mixed secant partials have opposite conventions for the order of differentiation. So the symbol in this notation, the derivatives are taken right to the left or right to left. So take note, taking right to left. Okay, right to left. In the subscript notation, they are taken left to right. Now remember this. So when you use this notation, okay, so they are taken right to left. But if you use this as a subscript, they are taken left to right. So the convention are logical if you insert parentheses. So be careful in this class because if you miss this, your answer is wrong. So be careful. All right. And on the other hand, the other one is, okay, I'll move this first. I just move it a little bit. So I want to emphasize something here, class. So the thing that I want to emphasize here is the secant part of the warning. Okay. So if you are having this notation, okay, so it's right to left. No, right to left. If you refer to this again, so the right to left. So differentiate inside the parenthesis. So differentiate inside the parenthesis first. Okay. Then here f sub xy. So this would be something like this. So you have to differentiate first from left, no, left to right. So differentiate it first what is inside of this inside the parenthesis, which is f sub x. Okay, so that's left. Then after that, you differentiate with respect to y. So here we differentiate partially with respect to x. So that is the left part. And then after that, the result will be differentiated partially with respect to y. And that is the right part. So differentiate inside the parenthesis first. Okay? All right. Now, for example, find the second order partial derivatives of the given function. So we're given here function of x and y given as x squared y cubed plus 4x to the fourth times y. Okay, so for our solution, we have uh, partial derivative of the given function with respect to x. So in this case, since we are differentiating partially with respect to x, so we have to hold y as constant. So in this case, we hold y as constant. Okay, so holding y constant. So look at here. So y is constant. So we have to differentiate only this for the first part. So y is constant for the second part or second term. We just differentiate this. So differentiating partially. By the way, uh, this one here, if we are going to take the partial derivative of the function with respect to y, so in this case, so we take here uh, x as constant. So in this case, we consider x as constant. All right. So when you're differentiating partially with respect to y, x is constant. When you're differentiating partially with respect to x, so y is constant. All right. So take note on this. So with respect to x, so it means you have to differentiate partially with respect to, or we have to hold y as constant when you're differentiating partially with respect to x. And here, when it's with respect to y, so hold x as constant. Okay. Now for the first part, so we have here partial the okay, this is the result. No, this is the first order partial derivative, no, with respect to x with respect to y. Now for the second order partial derivatives. Okay, so this is the result. You have to differentiate it again with respect to x. So still with respect to x. So here we still considered y as constant. So still y here is constant. Okay, so y is constant, but this time you have to look at this equation, no longer here. Okay, so looking at this, y is constant, 2 is constant, y is constant, so you segregate 2y cubed, so you just take the derivative of x with respect to x. So derivative of x with respect to x, so it means equal to 1. 1 times 2y cubed. Okay, so you have 2y cubed, right? So remember that. So you have 2y cubed as a result. Well, this is our second order partial derivative. Now here, again, y is constant. So y is constant, 4 is constant. So segregate 4 and y. So take derivative of this, 3x cubed, which is equivalent to 3x squared. 3 times 4, so that would be 12. So you have 12 x squared y. Alright, so that's why you have here as a result. So what we did was we take the partial derivative of each of the term. Alright, so taking the derivative of this is the result. Uh, Taking the partial derivative of this is also the result. Okay, and finally we have 2y cubed. Alright, 2y cubed, then plus 12x squared. Okay, so that's the first, or this is the second order partial derivative with respect to x. Next, this time we have to, we are differentiating partially with respect to y twice. Alright, so denoted by the symbol, or we have fyy, f sub yy, so that's the same. Okay, so this time, for this part, we need to, hold the variable x as constant. So for this case, x is held constant. Okay, so holding x as constant, and this time class we have to look at the original expression. Okay, so looking at the original expression, by the way, we got this already, no? Looking at the original. Okay, just to review it. Okay, so first we have to look at this, why it becomes like this. Okay, so we hold here x as constant, right? So we're differentiating the values with respect to y. So x is constant, it means that we take the derivative only for this part here. Okay, so constant, x is constant, x squared is also constant. So differentiating y cubed, so using the power rule, so 3y squared, 3y squared times x squared, so that is 3x squared y squared. Then again here, x is constant, so the derivative of y with respect to y is equal to 1, 1 times x to the fourth. So that's why we have here x to the fourth. Okay, now when we solve for the second order partial derivative, so this is where that we are going to see or look at or refer to. All right, so differentiating partially with respect to y, x is constant. So x is constant, 3 is constant. So it means we have to segregate this part and take the derivative only for this part. Okay, so derivative of this, that is 2y times 3x squared, so that will be 6. It will be 6x squared, it will be 6x squared, this will be x squared, then times y, right? Then how about this? So since x is constant, so derivative of this is 0. Okay, but the step-by-step process is something like this. You take the derivative of the whole thing and then you apply it individually. All right, so uh, after differentiating this partially with respect to y, holding y as constant, so we have this result. Okay, so as shown here, so 6x y squared. Okay, so next we have the partial derivative of the function with respect to y. Okay, so with respect to y, this is the result, right? Okay, I'll delete this first. Now we're dealing with this part now. I'll use another color. I'll use yellow. Okay, so first we have to take the partial derivative of the function with respect to y, which is already given here or done here. And then after that, we differentiate this with respect to x. Okay, so with respect to x, we just do something like this first. So this one here is taken above. Okay, this one is taken from here. Then we differentiate this one with respect to x. So this is with respect to y in respect to x. So the, the sequence here is that what is inside here, so differentiate it first, which is this one, all right, and then after that differentiate it with respect to x. So it means here this is the result of differentiating partially with respect to y, this one, and then after that differentiate it with respect to x. So with respect to x, so it means here we have to hold y as constant. Okay, so with respect to x, so it means 3 here is a constant, y is a constant because we have to differentiate it partially with respect to x. So it means we just take the partial derivative of this term with respect to x. So only x squared. We just deal with x squared here because y is constant. So it means that we have to take the derivative of the x squared here. So only x squared, only this part. So using the power rule. So power rule, this will go down. So 2x raised to the power 1. 2 times 3, this becomes 6. So this becomes 6xy squared. Okay, so we have the result here 6. Okay, I'll change the color. So the result here would be 6x y squared. You just copy y squared because y is constant. All right, so remember we hold y here as constant for doing this part. Okay, then taking the derivative of this with respect to x, so we have 4x cubed. Okay, so that's why we have here the final result. We have 6xy squared plus 4x cubed. All right, so first we when we get this one, we hold x or we held x as constant. Then after that, when you take the derivative of this again with respect to x, so y is constant. Okay, so the sequence here is that x first, and then y constant, x as constant, and then y constant. So next, okay, so again you take the derivative, what is inside, meaning with respect to x. So we are going to refer to this one here. And after that, take the derivative of the resulting function with respect to y. Okay, so do it step by step. So this is our partial derivative of the function with respect to x, this one here, which is this one, and we got this by holding y as constant. So now differentiate it again, but this time we have to hold x as constant because we are now differentiating it with respect to y. So this would be x as constant. So this time x as constant. Okay, so differentiating it with respect to y, holding x as constant. So 2 is constant, x is constant. So we have to differentiate only this part here, the y cube. Okay, using the power rule. So derivative of y cube, that is 3x squared. 3 times 2, 6. 6 times x times y squared. So the result here would be 6. Sorry, this should be 6. So this should be 6 because 3 times 2, that becomes 6. Then x, then so 3x squared, then y squared. Okay, how about this? So x is constant, 4 is constant, so we just take the derivative of y. So derivative of y with respect to y is equal to 1. 1 times 4x cubed, so we have 4x cubed left. Okay? Alright, so that's why finally we have this 6xy squared, this is 1, plus 4x cubed. Okay, so these are the answers. And you have to take note, class, that the third order, fourth order, and higher order partial derivatives can be obtained by successive differentiation. So some possibilities are the following. So you have, say, the third partial derivative of the function with respect to x is equal to the partial derivative of the second order partial derivative then with respect to x, or this is simply equal to f triple x, f sub triple x, or f sub x x x. Okay, and the fourth order partial derivative with respect to y is equal to the partial derivative of the third order partial derivative of the function with respect to y, or simply f sub quadruple y, or f y y y y. Okay, and so on and so forth. Now we have here an example, class, so I want you to try this and let's compare your answer and my answer in our next video. Thank you very much and see you again on our last two more videos for this topic, partial derivatives. Bye.